Welcome, everyone. Thank you so much for joining us this afternoon for this conversation between Dr. Lei Lani Stelle and Jason Gonsalves, a recent alum who reached out to us who is eager to share his experience as a graduate student. And we'll be talking all about his path today and his goals, his research, and connecting with Dr. Stelle. My name is Tracy Tellier, by the way. I am the Assistant Director of Alumni and Community Relations, and I've been planning all of our virtual events this year. Always happy to put together an event with any of you who want to speak with alumni that have shared interests. There have been a lot of great opportunities this year. So I thank you for joining us this afternoon. And I'll go ahead and just turn it right over to Lei Lani. Thank you.
Thank you, Tracy. So Tracy reached out to me to introduce me to Jason, I don't know, pretty recently, a few months ago maybe. And what's ironic is that Jason is studying marine science, but we never actually worked together when he was at the university because he did his degree in physics and then kind of came to the biology end after. After graduating, he did a program with Sea Education Association, which I'm also very familiar with because I've been on some of their cruises and have had many students do their programs. And I think it sounds like that really helped him discover some more interest in marine science. And he'll tell you more about the research that he did on that project. And after that, he decided to go to graduate school and is currently in the Physical Oceanography lab at Moss Landing Marine Lab, which I also have a lot of connections at Moss Landing, so it's been kind of neat to talk about that. His research is on air-sea interactions, and I'm sure he'd be happy to tell you more about his projects and what it's like being a graduate student. And he's also involved with the sleuths program, which involves sea lions. So I'm sure people would like to know more about that, especially some of my research students. And outside of the lab, he does a lot of outside activities, not too surprising. Gets a chance to dive in the beautiful Monterey Bay. He was a track and field athlete at the university, and he has recently started boxing, which is pretty interesting. So he'll tell us more about that, I'm sure. And what we'd like to do today is keep things very casual. And I asked Jason to just put together maybe some images and tell a little bit more about his story from his perspective. And then we really wanted to focus it on more of a conversation so that anyone here can ask questions. Jason will let you know whether he'd rather you wait till the end, or if you have questions, you can put them in the chat during, and I can help mediate that conversation if needed. But I will turn it over now to Jason.
Awesome. Thanks, Dr. Stelle. Appreciate it. How's it going, everybody? Dr. Stelle said we never actually worked together when I was at University of Redlands, but that's because I kind of flip-flopped through majors for a pretty long time. I was actually a bio major for about 2 years. So we were pretty close to meeting Dr. Stelle, but Dr. Norgren, when he was still at the facility, kind of wooed me into physics. So you can blame him for that. But yeah, so thanks for coming, everyone. I prepped a little bit of something about my current research endeavors at Moss Landing. I didn't, unfortunately, get any permission to use photos and video from sleuths. There's a pretty strict animal training guideline policy that I'm not allowed to share things outside of the spectrum of Moss Landing. But I can definitely talk about the program, and I have links to the Animal Training International site, which is the parent company of sleuths. And they have lots of great photos and videos and information about the program and the sea lions there. And I can talk about them, of course. It's my favorite 2 days out of the week. I work with them twice a week in a variety of animal behaviors and other aspects of animal training. So happy to talk about them. They're a lot of fun. So I thought I would just go through a presentation that I gave to the Physical Oceanography lab here at Moss Landing a couple months ago about my current research project with the Navy. I'm working with the Naval Postgraduate School in Monterey on a project that analyzes coastal forecasting predictability, which is kind of the avenue of air-sea interactions I'm going down. There's a lot of atmospheric science and meteorology as well, but I'm more focused on the oceanographic aspect of it. So I thought I would go through that really quick, and I'll share my screen here. Hope everybody can see this. Let's see. All right. Everyone can see that? Are we good? Okay, cool, awesome, sweet. So this is the project I'm working on with the Navy. The acronym is called CLASSY, which I'll go over in just a moment. And the idea from this kind of came about from this group at MPS called the Boundary Layer Processing Group. You can kind of see their names there on the screen. And they're working with a whole bunch of different institutions across the country, kind of listed down here below. Working on this project to improve the Navy's coastal forecasting model. They're currently using a model called COAMPS, which is this kind of superficial, bulk parameterized forecasting outlet that only really works in the open ocean. And when they've tried applying it to the coastal area across the United States, it gets really wonky, and the readouts are anywhere from a couple orders of magnitude to lots of orders of magnitude off from being accurate. So this project, the idea is to improve the ability to accurately predict weather patterns and forecasting in the coastal zone. Let's see. Awesome. So CLASSY, it's Coastal Land Air Sea Interaction. That's the acronym. And you kind of see in this first image here, it just kind of gives you a brief idea of what the zone we're kind of looking at. That's actually an image from the dunes at Monterey Bay. So this is the kind of the zone we're looking at where coastal forecasting kind of falls apart. It's mostly inhibited to atmosphere and ocean exchange. And the reason why this area is so unique is because you have a lot of other processes in the ocean that are occurring that don't occur in the open ocean. And I've kind of listed them on the right, but that can consist of surface currents, internal waves, wave shoaling, even like local topography, like especially those dunes right there on the beach. Those are creating huge physical barriers that inhibit wind and wave patterns. So the idea is that we're trying to accurately represent all of the physics in the coastal model, as you can kind of see there from that list. This right here is kind of a really complicated overlay of the different aspects of CLASSY. So the back image is the Monterey Bay, where I do most of my work in. And then the various numbered images are kind of a breakdown of the different aspects of the project. Again, this presentation had some technical jargon in it from when I presented it to, but you can kind of see how we're using both land, air, and sea aspects of the area to kind of create these little red squares in image 3. And the idea with those red squares is you can kind of bin land masses and water masses, and you can kind of create local parameters for atmospheric conditions and ocean conditions and weather forecasting inside those bins based on what's actually going on in the area. So it's a lot more specific, and it kind of gets a lot more of an accurate reading as opposed to applying a parameter that goes over hundreds of meters versus anywhere from 10 to 20 meters. So it's a lot more efficient in that respect. And these are a couple images of a lot of the variety, the different equipment we're using. The stars on the image kind of point to the pieces of equipment that I'm associated with. So the coolest one by far is the Twin Otter plane. I've been up once, and I'm hopefully going to go again soon. But the Twin Otter plane has a scientific readout that measures temperature, humidity, and it flies really low to the ocean surface. So it's been a privilege to be able to go up on that. But we're using lots of other things. There's lots of buoys, small boat operations. There's these things called helikites, and they have these devices attached to them called radiosondes, which measure temperature, humidity, and they have a GPS coordinate attached to them. So you can kind of follow their trajectory as they measure out. So it's really an all hands on deck project and process. And with all of these different aspects, we can create this weather profile of the coastal zone, and it's really interesting. This is one of the more interesting buoy pieces we have. This is called an Asus Buoy. It's an air-sea interaction spar. Noted by the image, it's really tall. It's about 6 meters tall, which is about 10 feet, give or take, a little bit more. And it requires a whole crew to deploy. It usually kind of sits on the side of a marine class vessel, and you kind of have to J-frame or A-frame it over with a lot of hands. And these are really cool because you can attach a lot of sensors to them. They have this really awesome hexagonal basically J-frame on the bottom that balances out the buoyancy factors of the ocean. So they kind of sit upright, and unlike most buoys, which kind of pitch and roll with the motion of the tide, you can have really choppy seas and they'll still remain exactly upright. So it provides a really good opportunity to get near current measurements and near surface measurements that you wouldn't normally get on a drifting buoy that has a GPS attached to it. The only downside is it takes an entire crew to go out and deploy these things, and it's usually a whole day of a process. So we have about 8 of them to deploy, so it's going to take at least 8 days to deploy all 8 of them. So it's a long process, and I think we've only got about 1 out right now, but we're going to start moving into the later aspects of the project pretty soon. So hopefully we'll have more out in the near future. So this is kind of a timeline of Classy and the aspects of it that I'm involved with, and what's currently going on. So the first segment, the first run, I suppose, has been going since March. It's supposed to end in June, and we've been up in the Santa Cruz area in the Santa Cruz Mountains, setting up towers, as well as some localized shore buoys and some near current buoys. And the idea is that we're trying to understand the atmospheric variability, which is kind of associated with these really strong upwelling and atmospheric patterns in the northern coast. So you can kind of see this zone right here. It's basically that black circled area right there that we're looking at with those land towers. And then from that, we'll move into the central Monterey component of it. And the idea with that is to analyze more of the oceanographic aspects of this project. It's at an angle versus the oncoming wind and water patterns that this middle area right here, represented in the purple, has a really high energetic surf zone. So you get a lot of energy from local waves and wind. So this is a great place to kind of get that high variability in temperature and humidity and any sort of energy conditions that we want to observe for the project. And then moving from there, we'll go into the phase 3, which is from August to October, and that'll be in Monterey Peninsula. So this would be the southern edge. And this is actually kind of harkening back to the study I did with SEA, where we're going to be looking at island conditions, metaphoric island conditions, because it's a peninsula. So we're looking at the topographic effect of peninsula structure and island structure on how that kind of changes current patterns and wind patterns, and how that affects oncoming storms and weather patterns as well. So that'll be the project that I'm part of. There's a lot of other collaborating institutions that are continuing this project onward after I'll be done with it. But this is the part that the NPS group, the Naval Postgraduate School, will be working on. That's kind of the brief overage of the project in a nutshell, without all the technical jargon. So I think that's it. Yep. So let me go ahead and stop sharing. So that was the sort of presentation I had in terms of Classy. I'm not sure what else you'd like to talk about, Dr. Stelle. I'm open to do questions, or if you want to move into another segment.
Are there any questions about the research that people would like to ask? I have a question about the research.
Yeah, sure.
I noticed you have different timing, different seasons for different locations. Does
Yes.
was that type selected on purpose, or is it just because you can't do it all at one time?
Yeah, so that's actually a good question. There was an intended purpose initially. There was some idea about some coastal variability, especially in the earlier months like March, where we have the winter season. So there's a lot more in the Monterey area. There's a lot more rain and weather in that timeline. So we thought the best time to analyze wind variability and more like atmospheric conditions would be when you had high turbulence and high weather activity earlier in the winter. But we actually didn't really see that much rain this winter up here, or weather by any means. So it kind of turned in having a purpose to, well, this is just the timeline, so we're going to go with it. And obviously a lot of the equipment takes some time to deploy, to deploy and put out. So I think that's what it ended up turning into.
So I also have a question. I know you can't share too much, but can you tell us a little bit about sleuths?
Yes, absolutely. I knew that was going to get there. I actually have lots of links too, so I'll put them in the chat after we talk. But yeah, so I'm in the physical oceanography lab, but I have the privilege of working with some really incredible animals. There we have 5 non-releasable sea lions at Sluice for a variety of different reasons. Their names are Nemo, Freya, Gaia, Callie, and Ariel. They're very, very sweet. It's 1 male and 4 females. Has with issues kind of ranging from Gaia and Freya were repeat stranders, and were repeat stranding enough that they were determined unreleasable. Freya has a proclivity to human contact, so she kept beaching herself because she wanted to be closer to humans. And then Gaia had random variability in her stranding, so we're not really sure why she was stranding. But those are some of the more simpler issues. Whereas Callie had domoic acid poisoning. She was birthed prematurely, and her mother passed away, and she had domoic acid poisoning, so it kind of passed on. So Callie's really interesting because she has weird brain capacity and chemistry, and her behavioral status is flipped. So she's not motivated by food; she's only motivated by the behavioral response. So we can't get her to eat unless she does a behavior for you. So when a trainer will go in a session, if you tried feeding her a fish, she wouldn't eat it outright. You'd have to do a behavior with her for her to eat. One of the ones she really likes is dance. She'll do dance, and then she'll dance with the trainer, and then she'll eat after that. And we kind of attribute that to the weird brain chemistry switch from domoic acid poisoning. So there's just a couple of the examples of the sea lions I work with. But yeah, it's a great experience. I'm still kind of working my way up in the training process. I just became a senior animal care person, so I'm just learning the basic training capacity right now. But when you start out, it's really kind of the back end stuff. Like when I first started in September, I was doing like bucketing and fish processing and medicine and stuff like that, and facility maintenance, and then you kind of work your way up into the trainer status, which I'm just getting into, and it's been about 5 or 6 months, so it's a little bit of a process. But it's kind of a great experience because everybody you're working with is also either a volunteer or an intern. So there's no really competition. Everybody's really friendly to work with, and everyone really wants to be there in terms of working with these animals. The only two staff that are paid are the director, who's Dr. Zaligs, and the curator, Dr. Scroven. And Dr. Zaligs, if you don't know who she is, Jennifer Zaligs is her name. She's very, very she has pretty high notoriety in the animal training sphere and marine mammal populations. She's worked with a variety of different animals outside of sea lions. She's worked with horses, lots of different like zoo-related animals, whales, seals, all kinds of different animals. She's trained several of them to go on and do appearances in TV, commercials, all kinds of different things. She's super well versed. And one of the links I'm going to share with you guys is actually to the parent company of Sluice, which is the Animal Training and Research International, which has a lot of information about Sluice and some of the other facets of Dr. Zellig's work. And you can actually see a lot of the images there and some video of the sea lions that we have posted up there that I've gotten permission to be posted. So I'll definitely send that your way. But yeah, I think actually we're still, it's kind of weird with COVID and there's other protocol we have to follow, but I think we're still accepting interns and volunteers. So if you're interested in the animal training world, we are taking people to come and volunteer and intern with us. So if that's something you're interested, feel free to reach out to me and I can set that up. And they do summer internships, semester internships if you're local, anything like that. So hopefully that was what you're looking for, Dr. Stell.
Yeah, that's great. It's an unusual opportunity. I had a similar one when I was an undergrad at UC Santa Cruz, working with pinnipeds. We had both a harbor seal and a couple sea lions. And so I was kind of the same thing. We start with just feeding them, kind of behind the scenes stuff, and eventually work with training. And then when I went on to do my master's in British Columbia, I was doing work with the Vancouver Aquarium, and I said, "Oh, I've got experience with training," and they're like, "Nope, you don't go near the animals. The trainers do everything." It was, you can do the research, but there was no opportunity. So, yeah. So people, students, anyone here would like to ask questions of Jason about that project and all, or other things?
Yeah, Jason, you mentioned briefly in your presentation climate change.
Yes.
How is this study that's going on going to intersect with issues of climate change?
That's a great question, Tony. Thank you. Yeah, so Classy is kind of unique because it has no, I guess, direct approach to climate change, but there's an indirect effect. And one of the biggest things with climate change is you're going to start seeing a lot of different local weather patterns changing, especially with sea level rise and harsher winters and longer summers. So the idea with Classy, especially, is that you're going to be able to account for that variability in forecasting based off the new kind of change that we're seeing. Obviously, we're trying to mitigate climate change, and we prefer not to have drastic effects associated with that. But on our current timeline, we're already starting to see pretty large degree change. Some of it almost always already irreversible. So the idea with Classy is, we'll be able to accurately predict weather and climate based off those changes in weather capacity. So hopefully that'll reflect in our study going forward and allow for better preparing Navy personnel and military personnel for inclement weather and other extreme weather scenarios.
I have another kind of tangential question related to that. In terms of all the implementation that you guys are putting studying the climate change in terms of like the weather, are you also doing anything in terms of the chemistry of the ocean itself based on the interaction between the air and the sea and more carbon in the environment?
Sure,
so
that's a good question.
Looking at like ocean acidification type stuff.
Yeah, absolutely. Yeah, that makes sense. I personally am not. I'm so much a boundary layer person, which is very, very physical. So everybody on my team is more interested in the physical aspect of the project. The University of Miami leg are the ChemOsh people, and they're going to be looking at chemical constituents and how that changes, not outside of technical jargon, how the transfer of kinetic energy from the atmosphere to the ocean, and the ocean to the atmosphere changes based off how the chemical makeup of the water exists, which is actually really interesting. And they'll be taking that leg over of the trip after our project is over. So they're actually the next part following us. The idea of Classy is it's about a 5 or 6 year span project, and when it'll be over, there'll be various aspects of the project. Mine just being a small part as the physical oceanographic aspect.
Super cool, interesting.
Yeah.
Thank you.
Yeah, of course. If anyone was curious, by the way, I put the 2 links in the chat. The first one is the animal training site, which is Jen's site, which has the specific information about animal training and some coursework as well. And then the second one is our cause box, which we're kind of crowdfunding sleuths right now. Running into some financial troubles a little bit with COVID, but everything seems to be working out so far. But that site has some really good images. It has some sea lion profiles, so it talks about the different sea lions, and there's some really good video. There's a good video of Nemo doing some behaviors with Jen as a thank you, and from some recent funding. So definitely check that out. Nemo is really good. He's 23. He's probably one of the most well-versed animals there. So you can kind of pick that up when he's sitting right there next to her. So
that's great. We'll definitely check that out. So I'm curious for the students in the group here that might want to know. I'm sure many of the classes you took in physics and whatnot were very relevant for what you're doing. But what did you take outside of your major that you felt was either just really interesting or very, surprisingly useful?
Sure. Yeah, that's a good question. I think it kind of all started when I took, if anyone's had Dr. Jenkins, Hillary Jenkins in the EVST department, I was in her first year seminar, Science of the Sea class. I don't know if they're still doing that one, but that one kind of kicked this all off for me a long time ago. But other than that, I actually ended up taking a lot of poli-sci classes when I was at Redlands. And I think I was doing that because I'm really interested in the political and policy aspect of marine science, almost more than the research aspect. And I'm kind of moving in that direction already. But I really enjoyed a lot of those classes. Stephen Woos is actually one of my favorite professors from Redlands. If anyone's ever had him, and he kind of got me into the policy aspect of marine science when I told him about my interest in the field a long time ago. So I took a lot of poli-sci courses. I took a lot of creative writing courses. I was a creative writing minor for a hot minute as well, because I really enjoy writing in my spare time, and I thought that was super beneficial in assisting my writing style. And definitely recommend if you're in science and you want to pursue a scientific career, taking classes in some form of writing, whether it be creative or scientific writing, because that's a really useful skill that not a lot of people have. Highly recommend. Yeah, anything to do with writing. The public classes are really cool. Took a lot of history classes, kind of sort of a history buff. I almost went down that direction as well. Those are the three big ones I think outside of physics. Obviously, the basic chemistry classes. I jumped shit out of bio right before the intro bio courses, and I would have had Dr. Aronson, but so I really felt bad about bailing out right at the last minute, but almost went into the bio world there. I think the two big ones outside of physics were writing and poli-sci though.
That's excellent, because I think most students who major in physics, that's typically not the the associated classes, but it sounds like it'll be very relevant for what you're interested in doing. So.
Yeah, absolutely. Yeah, I kind of tell a lot of people that I almost got stuck in physics because I was Russian rouletting with majors all of sophomore year, and I kind of just happened to land on physics when I needed to declare, to be completely honest and transparent. So I think when I graduated finally in being in marine science now, it was kind of a pivot out of physics. Whereas I'm still doing physics with physical oceanography, but especially with this program at Moss Landing, I have the capacity to do lots of other things as well, including animal training and some marine policy stuff as well. So I can have that versatility going forward.
Did you do a senior? I'm assuming you did the senior capstone in physics.
Yes.
Can you tell us a little bit about that project?
Yes, absolutely. That's an interesting one. I was actually Dr. Norgren, if anyone actually knows Tyler before he left, Tyler Norgren. I was Dr. Norgren's last student before he retired from the university. And my senior capstone was in astrophysics, which is another weird tangent that I moved out of. But my senior capstone was observing exoplanet transits in distant quadrants. So we have an observatory on campus, if anyone doesn't know that. It's on the second floor of Appleton. No one really uses it. But it's really, really cool. And I decided to spend that summer looking at distant quadrants of the universe, observing exoplanet transits. And if anyone doesn't know what a transit is, it's basically the earliest method that we've had where we can kind of observe exoplanets across other stars. And the way it works is you can see basically a dip in the bright curve of suns and other quadrants in the solar system of the universe. When that planet kind of eclipses the sun as it passes in orbit, so you kind of see this linear line of brightness from stars, and then when the planet orbits past it and creates a little mini eclipse, the brightness curve dips. And based on looking at that curve, you can determine how long that planet orbits that star for. And it was the earliest method of detecting exoplanets, but it's not really good because it only picks up exoplanets that are really close to stars. So they have to be big enough to see from the scale far away. So the only planets we're ever picking up are these really large gas giants that have no chance of having habitable life conditions. But it's actually a really cool way to see, it was a really cool way to see that, hey, there's lots of other stars out there that have planets orbiting. That's kind of where the whole race for finding exoplanets kicked off. And now we have a lot better, there's a lot more, more accurate methods of detecting planets, but that was one of the earliest forms. So I wanted to do my capstone on that. And we actually ended up picking up a transit, which was really cool, from this star called Kelt 9b. It's this really large, super large gas giant, and it's a low magnitude star, so it's super bright. So we got a brief curve, and I think it was like it had a transit time of somewhere between 6.5 to 7 hours. So I think the total orbit time was 17 to 18 hours. So it moved pretty quick around the star. So it was a really cool study. It was really cool. It was a lot of time sitting in the lab at 3 or 4 in the morning because the transit only happened at 3 or 4 in the morning. So. But it was an interesting project.
Yeah, that's great. It sounds really interesting. Who else? I'm sure other people have questions. I really want people to have a chance to ask.
How did you go about picking your graduate program?
Oh, that's a great question. Awesome. So it's kind of a complicated process. I think with graduate school, for any major and any career path, you have to kind of sit down and really decide what you want to do in terms of the specific niche in your field you're looking at. So for to take myself, after I got off the boat with SEA, with the Education Association, I really wanted to pursue marine science. And I wanted to be in a physical oceanography lab because I liked physics enough to stay in it. Um, but I also kind of wanted an experience that could give me aspects of marine science outside of the physical oceanographer, being a physical oceanographer. So that kind of geared my search in terms of looking at specific programs for what I wanted to study. And what I mean by that is that going out and finding faculty at schools and facilities and labs that had shared research interests as me, because a lot of faculty will post on their site on any academic page what their specific research interests are, and that's a really good way to kind of start out the search for graduate school in a science field and even a non-science field, like even like for history and poli sci, they'll like a faculty will always post like what their specific focus is and what they're interested in. So that's where I would always start, and then from there I would look at what papers they published, what articles they've written, who they're working with. I think that's probably the next step, because then you can can kind of get an idea of what you might be working on with that person and if that interests you, because every person has their own specialty within their own specialized field. So that kind of narrowed down the search. And then the third thing that kind of also steered me in my direction was references and just talking to people that I knew in my network. I'd actually met somebody when I was at SCA who highly spoke of Moss Landing Marine Labs, and that kind of stuck with me from that experience. So when I was looking at graduate schools, I remembered talking to her and her advocating for the program. And then when I did my search, I actually found a lot of aspects of Moss Landing that I really liked. So those are the three things that I usually tell most people to kind of use to kind of guide their graduate school search is find somebody that you can relate to, who has the same research interest as you, and then look at what they're publishing, what they're working on, and what their future work is maybe, and seeing if that meets what your interests are and what your ideas and goals are. And then from there, talk to people in your circle, network out, and see what their recommendations are. And chances are, especially with Dr. Still, I'm sure she's worked with somebody from some institution that you're interested in. They could probably connect you guys or advocate for the program. So talking to people, especially professors like that, is a really good option that I feel like a lot of people underutilize. So that would be my suggestion for looking at graduate programs.
I have a quick question. So you mentioned you were interested in the policy side of marine science, and have you gotten a chance to explore that at all with your job, or are you like going to in the future?
Yeah, good question. I actually that's the newest update as of today. I'm going to be working with the Monterey County district supervisor who just got elected. I actually reached out to her and asked if we could maybe collaborate on some policy aspects, and I'll be working with her office starting next month on some local marine politics. So we're going to be looking at some water runoff and stormwater intervention in regards to local pollution and trash. And she needs some help on the project. So that's, I think, my kind of avenue into the policy world that I'm going to be working on. But there's also a lot of really cool policy things I'm going to be planning on working on in the future. Next year, I'm going to be applying to the Canals program, which is with NOAA, Cal Grant, and Sea Grant members. And the idea with that one is if you get into the program, you spend a year in DC working with local legislators and federal legislators on marine policy as sort of like a marine advisor capacity. So there's definitely lots of opportunities. I think the program I'm currently in wasn't the best choice for a policy direction. I'm in a very much purely research based facility, but there are a lot of schools that have marine policy aspects that are much more developed than the one I'm at in Moss Landing, as well as just like other avenues of scientific policy, not outside of marine science too, environmental policy, local policy, anything like that. Hope that kind of answers your question.
And I think, in some ways, I think having a really serious research experience will make you much better able to communicate, especially with other scientists, and then hopefully share that with the policymakers. Because I think, as you know, many times the policymakers don't know the science. And so even if your program doesn't focus on the policy, you'll have the science expertise, which will be very useful.
Yeah. To piggyback on that, I tell everybody that I think the biggest aspect of STEM in general, even outside of marine science and physics and biology, just in general in STEM fields, I think the biggest problem currently in the world with STEMs is that we don't have a sufficient number of people who are effective at communication. I think science communication is a really hard skill, and it's kind of an art form that you have to learn. And a lot of the time you don't really get it in your undergraduate coursework because you're so focused on the science, learning the science and doing research and things like that, that you kind of get lost in the scientific aspect of science, whereas not so much the policy aspect and the communications aspect of science. Because at the end of the day, we all do science in our little, scientific bubbles and experts, things like that. But there's a whole, 99% of the world that aren't experts and don't do science regularly. But science affects all of their lives on a daily basis. So having that communication aspect is super, super important. And being able to, not only effectively communicate science, but want to effectively communicate science and do that community outreach. And I think that's why I'm moving in that direction, because I was kind of seeing a lack of capability and people, having the ability to do that, and make those changes and speak on science in a positive light and infer to other people. So it's a growing field. It's a lot of fun, and if if any of you are scientists or emerging scientists or in your undergraduate programs, I definitely recommend taking courses and practicing your communication, because it's super important.
Excellent. Yeah, and I think that's great advice for students and for faculty to emphasize as well. So, other questions from the audience? Well, I have a question. You mentioned that you did the C program. Now, it sounds like, did you do the summer research at the university as well?
Yes, so I did the SSR program at Redlands, the Stafford Summer Research Program, the summer before my senior year, and then I did SEA the summer after I graduated. So they accepted me as a recent grad for the program.
Are there other things that you did outside of class that you found really useful or just enjoyable?
It's a good question. I think being at Redlands specifically was beneficial to me. Harkening back to the communications aspect, because there's so many great social opportunities on campus at Redlands. So I think outside of the summer research and SEA, which I think were my main scientific outlets when I was a student at Redlands when I had just recently graduated, I think getting involved socially and in the communicative aspects of Redlands was super important. I mean, I was a 4-year athlete. I was on the track and field team all 4 years, and I think that was a great opportunity for me to well, it's really hard to kind of sit in the classroom and be a scientist all day. So it was a great outlet to kind of in the afternoon to go out and practice with the team and have that team aspect and talk to other people. So I thought that was super important. And I was in Greek life at Greek life after my sophomore year, and I think that was super important. That was a great opportunity. And there's lots of other things that were going on that I wish I'd taken advantage of, but I just didn't have the time. So I think a general answer to the question would be just try as many things as possible. Anything that has like a community aspect, like that's super important. I think another one that I really wanted to apply for and try was Maroon and Gray ambassadors, but I never got into that. So anything like that is super important, especially when you're dogged down by, you know, science and numbers and math all the time. So it gives the brain a good break. So which is sorely needed a lot of the time. So
That's great. It sounds like you were very involved in a lot of different things, which is, I'm sure, been very beneficial. So, other questions from anyone like to know more about Jason's path or current experience?
What May term experiences did you have as a Redlands undergrad?
May term, awesome. I love May term. Yeah, I did the Italy trip with Tyler, the May term of my junior, right before I did SSR, my summer research. So I got to spend a month in Italy doing astronomy. So the class was following Galileo's experiments. So we spent time in Rome, Venice, Florence, and the Amalfi Coast, kind of just going around and doing and recreating the same experiments that Galileo did, which was a really fun class. It was probably like one of my favorite classes I took at Redlands. I think that was it was only the only time I got to go abroad too, so that was like my abroad experience. So that was definitely rewarding. And then the other midterm class I took was Steve Woo's, where I met him the first time, which was political geography, which was a really interesting class, and it kind of analyzed local Redlands politics. We spent the May term doing like community outreach and kind of getting the geographic layout of different political spheres in the local community. So that was an interesting class as well. So definitely had some good experiences. I think the Italy one kind of trumped over Steve's class. Sorry, Steve, but enjoyed both experiences a lot. Definitely valuable.
Yeah, I have to say, I am partial to travel May terms. They're a pretty amazing course. Other questions from anyone?
I think did Conrad have a question? I saw you raise your hand if you had a question.
Yeah, I was gonna ask about the internships you did, but you
Sure.
just answered that. So
No worries. Yeah, no, I spent my junior summer at Redlands doing the summer research program, which I think was a good choice. If you're in if you're pursuing a science field, I highly recommend doing some form of internship in your junior year or your senior year, whether that be an REU outside of the university or in the SSR program. I think it's super valuable, especially because it's one of the first opportunities you'll get at doing your own research project, which has a good chance of turning into your capstone as well, which for which it did for me. So I recommend that for sure. And then I was at SCA, which is the Education Association in Woods Hole, Massachusetts, for the following summer. I'll put a link to that as well before this is over, because I think that's a great program too. Not even if you're not even just if you're just interested in marine science, but it's a great scientific program and it's fun. You spend 6 weeks on a brigantine, and you do a bunch of science, and you also do sailing and ship skills. So you basically become crew. So you're helping with watches and sail handling and things like that. So it was awesome. It was a great experience. Those are the big two, and then. Yeah, I think those were the two undergraduate experiences I had, and then that's when I kind of moved right into Moss Landing in my graduate program. I took a year off in between, which ended up being the worst time to take a year off because COVID. But it worked out in the end. So.
So I have a question about graduate school. What do you find to be the most how does it compare to your undergraduate experience? What's similar? What's different?
Yeah, that's a good question. I think the biggest thing for me that was really striking, basically from day one, is the amount of personal accountability that changes. So as an undergraduate, it's kind of your first time being on your own and being responsible for yourself and your classes and other things that are going on outside in your life. But I think there's an aspect of there's someone kind of always there to catch you as you're going through in your undergraduate program. When you're a graduate student, a lot of you're treated as a professional, master's or PhD or med school, like you're considered a professional, so that you're treated as such. So there's no one's going to be no one's going to remind you of deadlines. No one's going to be hey, like there's this opportunity, like just shooting you a heads up, or like hey, I need you to get this done. It's just kind of up to you to put in the work and take the responsibility for what you want to do and what you want to get out of the program. I think that was the biggest difference for me. Being in a position is being respected and treated as a professional, as if your professors are not even really your professors, and your advisor isn't really your advisor. They're more like your colleagues, which is super important. And it also feels great to be treated in that way, but also it heightens the stakes a little bit in terms of like, hey, you need to be on top of this, and you need to know what your deadlines are, and you need to have the self motivation to stay on top of your research or your thesis or whatever your job is, and things like that. So it's a great kind of in my opinion, like first like real experience where you're taking charge of everything on your own. So that was like I think the biggest difference for me.
And as we mentioned the other day when Jason and I spoke before, if students aren't careful, it can be a very long process because of that.
Yes, there are people at Moss Landing. So it's a 3-year program, but there are people who have taken their time with their thesis and not been as proactive, and they're here on their 4th or 5th or 6th year, and at that point it's just like, oh my goodness, you know what I mean? So you want to obviously take your time and be responsible with with your program and get the most out of it, but also that personal accountability aspect. You got to make sure you're on top of things, so you're not staying in an academic program way longer than you need to be. So.
So do we have any other questions? Well, Jason, if anyone has questions at a later point, are you comfortable with them reaching out to you?
Yeah, absolutely. I'll put it in the chat right now too. I'm also just dumping a bunch of links in the chat right now if people are interested. I think Tracy's gonna send them out as well. I sent them on an email list to her. But I'm gonna put my email here in the chat. You can feel free to reach out to me anytime in that email. That's my academic email, so I'll respond to it pretty quickly. I usually look at that every day. And then some of the other things I was kind of throwing out there is I linked the SEA program, which is really cool. Definitely check that out. The 4th link is a list. Actually, it's a really good compiled list from the National Oceanographic Science Bowl about pretty much all of United States-based programs, master's and PhD in ocean sciences, earth sciences, atmospheric sciences. It's got a really good comprehensive list of a lot of those programs. It's actually one of the sites I use, and I kind of went down the list as I was looking. So I think that's definitely a good one to look at if you're interested in that field. The other one I just linked is the link to the Navy Marine Mammal Foundation. It's National Marine Mammal Foundation, but it's run by the Navy. They have internships for animal care and training. Really good. Highly recommend. I didn't unfortunately get to do it when I was an undergrad, but I would have loved to have done this program, which is really cool. Gonna throw in a link to Moss Landing. That's the Moss Landing site. And then another one I wanted to throw in was Old Dominion. Old Dominion is in Virginia. They have a really good ocean, earth, and sciences program. I actually almost went there. It came down to there or Moss Landing, and I ended up picking Moss Landing. But a lot of the faculty there are really great, and they have an absolutely insane program. So there's just a couple opportunities if you were curious. So that was my link dump. And then you can always email me at that email address as well. I'd be happy to answer any questions you have.
That's great. That's sure very helpful for a lot of the students. And we really appreciate you taking the time to talk with everyone and share some of your experiences. It sounds amazing.
Yeah, it's been a pleasure. Thanks for coming, and I absolutely am in love with the field, and I love what I do. So happy to share. So.
And thank you, everyone, students and alum and friends, for coming to meet with Jason today. We appreciate it.
Thanks, guys. Appreciate it.
Thank you. Thanks, everyone. Thank you so much, Jason, for sharing your experience. Your passion is so evident for what you do, and we're very proud to count you among our alumni. I'm very excited to see everything that you accomplish in the future. So thank you all so much. And thanks again, Jason and Lei Lani, for facilitating the conversation. It was a wonderful opportunity for us. Thank you.
Thanks for having me. Appreciate it.
Thank you.